Hello everyone, and welcome to today's session, the use of power assets in the provision of telecommunication services. I'm Ashley Turan-Ord, your host for today's event, in partnership with Smart Energy International and the Prime Alliance. Within the digitalisation of utilities in the framework of the energy transition, telecommunication services have become one of the requested pillars, as they provide the information connectivity required in an increasingly distributed environment. The solution is a mix of providers and technologies, among them the use of their own power assets, which contributes to achieving the most efficient solution. In addition, the power assets can be very well used to provide telecommunication services to third parties contributing, as well as to adding revenues to the utilities. Today's discussion welcomes a panel of experts who collectively will unpack this topic and answer your burning questions. I would like to introduce you to our official host, Miguel Angel Sanchez Fournier, General Secretary of the Prime Alliance. He was the former Director of Smart Grids at Iberdrola. Setting the scene for us now is Miguel. The screen is yours.
Thank you. Thank you very much, Ashley. Good morning, everybody. As Ashley has said, I am acting today as the General Secretary of Prime Alliance, an industrial association founded in 2009 with the purpose of ensuring an efficient telecommunications solution for the, at that time, envisioned requirements of smart metering. I have the privilege of being supported by Julian Stafford, the Technical Director of the EUTC, an association with more than 25 years defending the importance of telecommunications within the European utilities, and to which I know very well because I have been served as its chairman for a long time. Both Prime and the EUTC have agreed in considering this as a great opportunity of addressing together this event. And I hope that it will be a good example of future collaborations. Julian's background includes a wide range of work in rural broadband and mission critical communications, having started work in the electricity industry in Manchester, UK. He has dealt with implementation of a wide range of systems. Julian also worked with cable and wireless, including a smart metering solution. I also have the privilege of introducing shortly to you the speakers in the panel. And I know very well both of them, and believe me, they are really experts in the subject that we are dealing with today. Dr. Alberto Sendin is head of Smart Grids at Iberdrola, company that he joined in 1998, where he has been working with different roles in telecommunications and smart grids. He is author and co-author of 8 telecommunications books and has been involved in telecoms and project lecturing. Now, currently lectures at Comillas University. Marcus Kofsas, with over 10 years of experience in the semiconductor industry, is the team leader of the broadband power rollout. Smart grids, network development, and in the German utility E.ON. He is responsible for the coordination of smart M2M communication at E.ON and Bayern communication in low and medium voltage, as well as the E.ON broadband power line rollout. Now, and as a way of setting up the scene, let me just make a brief introduction. By the way, may I see the slides? Yes, the slide that I wanted to use for this. Let me just make a brief introduction before passing to the important content of today, which is really the panel. I was referring earlier to the telecoms needs of smart metering as the objective of the Prime Alliance. And now, let me ask you to think in the need of telecommunication services for the utilities now and in the future. Don't you think that, especially in our distribution networks, we have many, I would say a major part of our assets without connectivity? And I say connectivity meaning exchanging information for its status and even transmitting information or actuation need orders. Power networks are extraordinarily dispersed in geography, diverse in their installations, and when they were installed in many cases a long time ago, they did not need telecoms connectivity. Don't you feel that there is a fundamental change coming along? Especially today, when the power networks are being considered as the central target for contributing to the energy transition by means of integration of distributed energy resources, electrical mobility, and supporting the needed increase on energy electrification, power networks will become smart grids with connectivity, and they will serve as our society is requesting. And how to provide this connectivity? Answering two simple questions. One, knowing technical requirements of the connectivity. And second, knowing the technology alternatives to cover such requirements. They are simple questions, but looking then into detail, complex, very complex for their answers. First, functions to be provided and location of the asset. Believe me, there are more differences than similarities. Of course, you can group and categorize them, but the truth is that each one is different. Second, the capacity to transmit requested information with its allowed latency, as well as the coverage served by a party, and always targeting the efficiency. Because there are many available technologies and services providers, but please, thinking always about the degree of control that you can keep. In my many years of responsible for telecommunications in Iberdrola, I had very clear that upon a service failure, I could not blame the responsibility to either Telefónica or Vodafone, just for putting some examples. You see in the slide the simple summary of the example of Iberdrola, which is a representative of many others in Europe. Let me conclude this introduction highlighting the most important factor to answer these questions and provide the proper decisions. People, and I underline this, people. The people fully aware of the power technologies, processes, and requirements, as well as the telecoms technologies. They are the base. And without them, the adopted solution will not be the optimal from the point of view of the efficiency. Only knowing these two technological areas, you will be able to enhance efficiency using power assets. The panel is having enough of it, enough of knowledge, and let's listen to them. I conclude my introduction and I pass now the screen to Julian. Thank you.
Miguel, thank you very much for the introduction. Yes, I'm Julian Stafford, General Secretary of EUTC. You can all search EUTC online if you like to find out what we do, but we do a huge amount of representation for the collective of European utilities. And I must say it's fantastic to be invited to chair the session today, which is a really positive indicator of the type of collaborative work which Prime Alliance, EUTC and a handful of other organisations work on, especially where there is overlap between the areas of our interest. So I'm really pleased, as already said, between Miguel, Alberto and Marcus with some excellent presentations this morning and greatness on the panel, shall we say. So without further ado, I will hand over to fellow board member and friend Alberto Sendi of Iberdrola for the first presentation. Alberto, over to you.
Hello, good morning. Thanks for that, Julian. Thanks for that, Miguel. Thank you for this opportunity. It is great for us to show you, let's say, some more insights of what we do and the needs we have. And most of those needs are really connected to the grid assets, and that is really key for the messages we want to deliver. We have prepared some slides to help us deliver these ideas. Hopefully they are useful for us to follow them. First thing that should be highlighted is that the smart grid is, well, I wouldn't say plainly, but it is an evolution of the grid we have. Clearly, this evolution, it was highlighted by Miguel, is helped by many things and by many aspects of the grid evolution itself, but also by the help of connectivity. Connectivity is a really interesting concept for us utilities when it comes to managing our grid assets. We cannot observe, we cannot control those things in which we don't have telecommunication means. What you have on the screen, and if you click again, you will see that there are some dots appearing on the screens. This was, let's say, the areas in which you had to provide services when you were a traditional utility. We are thinking probably 30, 40 years ago. We were just aiming to reach corporate offices. We were aiming also to reach primary substations that will appear when you click again on the slide. And then if we click again, we will see the simile of building these kind of things when you think in roads. Basically, this is creating motorways. Creating the backhaul of a grid such as this one is basically producing the same effort as producing the big motorways in terms of reaching distant places. If you click again, we might be going to the next slide, one more click, and then we can see which kind of things have been helpful for us to reach these kind of long-haul networks. It is relevant to refer to optical fiber cables. For those of you that are not familiar with this, these are some pictures depicting the shape and the places where typically those cables are installed. Many utilities do have an extensive plant of optical fiber cables, which are deployed both in overhead lines and also underground. These have been really helpful and have been developed over the last 30 years to cover basically long distances, and not only that, based on the new evolution of telecommunications, also appearing closer to, let's say, the homes and secondary substations. If we go to next slide, you will see the big challenge of the smart grid concept. Being evolutionary does not mean that things are not changed. First thing to notice is that our intention as utilities is to cover the most relevant assets in the grid. This is expanding from the core to the edge. Clearly, we want to cover first the primary substations we mentioned. If you click again, you will see how secondary substations are also the thing we need to reach. And also, if you click again, you will see a number of points which are relevant in more rural networks. I will refer to them with the word reclosers. If we click again, we will get a glimpse of the difficulty. We are not just building motorways, which are, let's say, investment intensive, but clearly we are now focusing on different areas in which highways or local roads or even tracks could be more difficult to pave. So you see how this is the challenge of connectivity. If you click again, we can go to the way in which those assets I was referring to have been constantly reused. Here you have the example of the optical fiber I mentioned before. Be it for the long haul or be it for the challenge of getting access to primary and secondary substations, we have had a track record of reusing the same assets, just changing the different elements that were around them. You see the cables on top, you have PDH technology, old-fashioned obsolete technology now. You see below SDH, to which PDH was connected. You see below DWDM. In the end, the art of reusing these existing assets that are laid on poles is key in order to implement the new features that are required for the evolution of the telecommunications connectivity and the smart grid in that realm. What you see below, it is basically the group of, if you click again, the group of different layers of things that are appearing and how at different points in time in history we have been using either just radio with PDH or just optical fiber with SDH, or we have placed the WDM on top, and even PLC power line communications I will refer to later. If we click again, we might be going to the next slide. Next slide is showing, let's say, the challenge in terms of architecture. What you have on top, and if you click again, there will be a line showing that part I'm mentioning on top. You will see a traditional telecommunications network that was just intending to reach those primary substations. However, with the smart grids, it comes the first challenge of the first instance implementation of the smart grid, which is intending to reach secondary substations. Secondary substations, utilities have tens of thousands of them, are needed because they are the next step into the evolution towards the smart meter. The smart meter being, let's say, one of the main components of the first smart grid implementations. As you see on the left-hand side, you see access, you see tens of thousands I referred to, and then you see IP communications. When you focus on the right-hand side, you see a green square, and it mentions Prime, which has been the technology being used by Iberdrola to give these smart meters, let's say, this intelligence required. But you see that it says non-IP communications. This basically refers not to a technology limitation of Prime protocol, but refers to the intention behind this first smart grid implementations, I would say smart metering implementations. We were not intending to provide grid smartness to its limits when it came to the smart meters. Let's go to next slide. Next slide is showing how, apart from the figure we have seen before, how we are mixing different technologies to achieve the same goal. Miguel mentioned it at the beginning. Utilities are not just with their own private networks fulfilling these requirements of smart grids. They are also using third-party networks. They are using also commercial services being provided by the market. So you see on the left-hand side to the top, you see cellular, 2G, 3G, 4G, eventually 5G. You see also XDSL. You cannot see because it is not there, but it is already in our network. FTTH, which is the optical optical-based services provided by different telcos. In the end, what we try to do as a utility is to make the best of this technology mix and to offer, let's say, an end-to-end service experience to our customers, internal customers, which are dealing with smart grid concerns. If we move on to the next slide, it is trying to show part of the challenges that we have with these commercial services, and specifically I'm referring there to cellular mobile communications. Most of you are familiar with power grid infrastructure. What you see is the different towers that we are using to put the power lines themselves. You see how those power lines are along the road, but you see there is a tower there which also takes those power cables up to the base station, and the base station is what you have there on the left-hand side with the antennas. Clearly, we have a challenge here. If you click again, you will see how. If we don't have power in those premises, we will not have a wireless service. And if we don't have a wireless service, we will have that this base station, these antennas will not work. So there is a kind of situation here in which there is either the need to put batteries in these places or complementary to create a resilient network. And in the same process, clearly there are some services connected to the power line services that we cannot cover with wireless services because they rely on our service. So we cannot solve our problem with services depending on our services to work. So I don't know if this was clear, but let's move on to the next slide that shows how power line communications that I referred to at the beginning is a technology that has been used by us utilities to fill in the gaps of different commercial services that were not already there or different optical fibers we could not lie. You see that power line communications reduces the asset we have, which is the one intended for the electricity service delivery. This is not new. This was done in the telecommunications industry many years ago with ADSL. The big and important news for utilities is that this technology relies on our assets. If we control our assets, our power lines, if we have them well designed, we can use these technologies to reach every corner of our grid, because power lines are everywhere in our grid. Let's move on to the next slide. Next slide is trying to see what we have for the future, where we come from and what we have for the future. If you focus on those circles, on the left-hand side, you will see the medium voltage grid. Medium voltage grid has been the desire of the smart grid, the traditional smart grid. Automation in this medium voltage grid is really helpful to provide a good electricity service. We have been using that network to host PLC-based solutions, and we are able to provide remote control services based on broadband power line communications. If you focus on the right-hand side, the low voltage grid has been used also with power line communications, reaching the smart meters, reusing those assets we have just to provide the smart metering services. These smart metering services are typically narrowband. They are not intending to go farther than the smart meter. However, if we have the chance of putting broadband power line communications in the low voltage grid, what we can get is this evolution from the smart metering to the smart grid into the low voltage grid. The low voltage grid is basically the next frontier in terms of providing solutions which are extending the smart grid into the customer. If you click again, you will see that to the right-hand side, explicitly referring to this low voltage grid automation. And if you start clicking, you will see different images that try to solve the different concerns we have around solutions that are just being placed over services provided by commercial telcos. There are things connected to the priority we cannot receive because that is not mandated in regulations when it comes to these wireless licenses. We have design concerns, we have battery-related concerns, we have coverage concerns. Smart grid is reaching every corner. Telecommunication services provided by public operators is not reaching everywhere. So we have some limitations there. Let's move on to the next slide, which it is the last one. Some hints for the future. Clearly, we cannot go farther than hinting what we think we will have for the future. Infrastructure, assets and infrastructure is basically coming to the same point. Both energy, specifically electricity and telecoms, are intensive in terms of infrastructure use. If we think on electricity and also if we think in telecommunications, we see that they are also essential services. There is a big relationship among these two worlds. We see that the smart grid evolution is going deeper and deeper into the grid. Smart grid is an evolutionary concept by itself. If telecommunications are not where we need to make the grid smarter, we need to produce those telecommunications. And don't forget that the smart grid paradigm is making the grid smarter in the sense that it is self-healing, resilient, and providing the grid quality electricity service. For that, it is instrumental to have grid observability and automation of our activities to be capable of doing this. And this is the end of the slides. Thank you so much.
Alberto, thanks very much for an excellent presentation, excellent graphics as always as well. And yeah, this just reminds me in my own mind that kind of two key cornerstones of what we're discussing this morning in terms of the electrical infrastructure and telecommunications and the sharing. So there's the active sharing of using the electrical conductors to carry telecommunications signals in the way that they may be considered a crude coaxial cable of some type. And then there's the passive infrastructure sharing as well, where actually the physical towers and ducts that the energy companies own and operate can be used to support fiber optic cables, both for enhanced smart grid connectivity and for connection to other things like 4G and 5G and eventually 6G base stations. So that's really interesting. Alberto, I'll open just with a couple of questions. The first one is kind of a two-part question. Thinking of power line communications and broadband power line, these are now quite mature technologies that have been around for at least 15 or 20 years. And how is it that, you know, with Prime Alliance and one or two other standards around Europe and around the world, that those technologies have been very successfully deployed in some countries, but hardly at all in others? Have you any ideas or thoughts as to why that might be?
Yeah, there are probably several angles and not right or wrong answer around those topics. Clearly, I think there is one angle which takes into consideration the differences in the grids among the different utilities, even among regions in the same utilities. You don't have the same assets, so the suitability of each grid to the different PLC technologies is to be considered. There are some places in which that is more easy or more straightforward. I think there has also been some aspects connected with the different penetration of smart grid at different historic periods. Probably not all utilities have been with the need to provide the same service at the same time, so they have used different technologies available at each point in time. And this takes me to the availability of standards. When you try to use the technology, if there is no standard till that standard develop, you clearly have a need that you need to solve. So not having too many available standards in some flavors of PLC has not been helpful for some utilities to adopt power line communications. However, I think there are several other aspects. First one is this is not just technology, this is availability of products. If those products are not available when they should, or if utilities are not able to present a business case for vendors that do need to provide these products, well, this is again a chicken and egg situation that takes us to situations in which PLC has not been used because of the lack of products to serve that market. And last, and probably not least, the comfort of trying to use wireless, for example, versus power line communications, puts you in a situation in which you are not forcing things within your company. It is not easy always to connect the electricity world with the telecommunications world. If you try to put them together, if you try to install telecom things inside electricity devices, that is not comfortable to some of the technicians. So this is a process ongoing in many companies, and it takes a while till you solve those kind of situations, internal situations.
Okay, no, that makes sense, Alberto, and I think echoes some of the other conversations I've had with other people. So the second part of this question, I guess, is we've seen what power line communications can do, and I'm very pleased to say that even my own electricity meter here in Valencia has got a Prime Alliance sticker on it, so I know that this technology works. But do you think as we progress into the world of smart grids and increased connectivity at the edges of the network, that there's a case for more R&D and almost a next generation of power line carrier technologies with even greater capability and throughput and numbers and so on as well? And of course, as you mentioned, it's probably unlikely that without a large utility such as Iberdrola and others behind these standards that they would have ever got off the ground. So I just wondered what your thoughts were on that, Alberto. Is there going to be a Prime Alliance plus type standards description?
Yeah, probably in utilities, we're also used to using other technologies being used in other markets. And clearly, let's say things come a bit slower when it comes to being adopted by utilities. The thing is that utilities do have a need of expanding into the low voltage part. Low voltage grid, it is the big unknown to many utilities. Things that happen there are not still observed. So clearly, if they are not observed, you cannot solve the problems they have. We are getting more capillary. We are taking automation to the low voltage. Low voltage is everywhere, basically everywhere. Telecommunications are not everywhere. So I think there is a big synergy between power line communications and low voltage automation. Probably if we need low voltage automation, that will only come if there are good power line based communication solutions for that, because we are not going to find answers from the plain telecom market. So we have the need, we have, let's say, the technology which is already there and it is working. What we just need is that applicable on the field and start getting results. So for that, the standards will be really helpful and products will be coming because the need is already there and the market is already prepared.
Okay, no, thanks, Alberto. So I have just one more question, and I'll try to keep us on time and on track for the next speaker as well. But I'm interested as well that for several years now, there's been pieces of legislation in place implemented by the European Commission. So things like the Broadband Cost Reduction Directive, the new Electronic Communications Code, both of which, in theory, should encourage and really supercharge the amount of infrastructure sharing that can happen, not just with utilities, but also with highways and railways and so on. But in reality, there doesn't seem to be the expected take-up or activity in this area. I mean, what are the barriers there? Are people ignoring this? Are they shy about it? Do some people see it as a lot of additional hassle, whereas maybe other companies see it as a big potential revenue stream? Just interested in your thoughts on that.
Well, let's say that this process of using and reusing assets to put optical fiber cables started long ago, and it was kind of boosted by the regulation that came in Europe clearly over 20 years ago. I think that there have been utilities taking advantage of that situation and some telcos that have benefited from that possibility of having those optical fibers supported by power lines and the towers themselves, but the poles. Now, what we see as Iberdrola, we started that process. We built many of our cables for that purpose, just to help ourselves, but also to help others. We did that in the long haul, and the long haul is really well prepared to host those cables. Now the challenge comes when you don't have those poles in, let's say, urban environments where probably the base stations for 5G and these kind of things are needed. So when you try to put a cable and put it underground, first thing you need is a duct. Those ducts are not, let's say, the business as usual for some utilities, so there are difficulties. If you are trying to reuse the ducts which are taking power line cables, that is challenging from the safety perspective and eventually even from the security perspective. So what we see is that despite this directive 5-6 years ago, this market has not boosted because we are still seen as the last resource. And it is so because the difficulties are great. It is not so simple to just think that you can place an optical fiber cable close to a power line. It is not as simple. And there are other ways of getting a simpler access, which is getting access to, let's say, municipalities that they have really good ducts, or even to other telcos that who do have those ducts and well-prepared sites. So clearly, we still see that utilities are the last resource, and it is just for the difficulty of doing that, let's say, in a very straightforward way.
Okay, thanks, Albert. So that's really useful, and I think this is going to stimulate a lot more discussion as well. So Alberto, thanks very much for the presentation. I can spot that we've got a few questions coming through on the chat, but in the interest of timing, I think we'll save those for the end. If we don't get a chance to answer them in the session today, we're just over the halfway mark, then we'll probably be able to take those offline, and the speakers, panelists can maybe reply independently. So thanks again, Alberto. And I would now like to introduce Marcus of E.ON, who's going to give us an equally interesting presentation on the situation in Germany in terms of smart grids and what's happening within E.ON. I would say as well, E.ON, very, very impressive organisation, huge track record of achievements, and very significant contributor to the work of EUTC and numerous standards over the past 10 or 20 years. So, Marcus, I'll hand over to you. Thanks.
Julian, thank you very much. Okay, first I'd like to say thanks to Alberto. He gave a really great explanation of the evolution of telecommunication in utilities itself. And being honest, in E.ON, it's not much different at this point. And so far, we have a rather good infrastructure for communication. already for high voltage, connecting primary substations. And now if we go to our first slide, we see that by what's currently going on in Germany, but not all over Germany, only Germany, I think all over Europe, the decarbonization, we everywhere have decarbonization programs, we have energy transition. And this now is really putting the pressure for smart grids, but smart grids especially in medium voltage, in low voltage, where we still have certain weaknesses in communication, in existing nets, and how we can operate. And just looking to Germany, when we see that we expect climate neutrality until 2024. We have a massive expansion in renewable energy. We have tremendous amounts of PV photovoltaic plants popping up on private households, on rented buildings. We have a program of 50 million in mobility until 2030. All this is happening in low voltage, and now there we have really to get active. And one of our activeness at this point is that we really have to equip our secondary substations with intelligence. We have to have them controllable. We have to monitor them. But in Germany, it's not only the secondary substation taking part of the smart grid. We also have the smart grid in Germany doesn't stop at private households. We have the smart meter gateway, in which we might have done a unique way so far, that takes over control of private appliances like PV plants, like heating, like private wall boxes, charging stations, and all this is happening in low voltage, and therefore this puts pressure on us, where we have to set up our communication infrastructure, and this not over a long period. This has to be done quickly. You cannot put fiber cables to each substations, despite of the amount of money it would cost. It's simply too long in time we would take for. And therefore, if we move to the next slide, would you please move to the next slide? Okay, thanks. We are clearly insisting of a communication mix in Germany. And I mean, Alberto also mentioned, it's not one technology that is providing the absolute solution for everything. We need to combine all the different solutions, and we really have to focus on availability, but also reliability and security. And sufficient bandwidth for these certain appliances. For some we need more, for others less. And in some applications we have to have blackout safe, or we have to provide the priority to utilities to use communication rather before any private communication is going on. And therefore we are currently working on a mix, or we partly already have set it up, that consists of course, power line. Power line is a very important part for us to reach and cover the last mile from the secondary substations to the private households, to connect our smart meter gateways, but also to gather and collect more information of the situation of the low voltage grid itself. But we also use public mobile. We use DSL installations. DSL more for connecting and building the backhaul for the secondary substations. And what is also maybe in Germany a way, it's not unique, other countries are also doing it, but what we also start is building up a private mobile network, completely utility dedicated. We are using the 450 megahertz to set up a mobile net all over Germany that is used for connecting substations, for connecting primary, secondary substations, but also connecting the private houses, some of the smart meter gateways. Thus, we have a bench of for each appliance. For the substations, for the private houses, for the smart meter gateways, we have a subset of different technology we can use that at least one is clearly available and that provides us at least a 95 or 98% percentage of availability of the communication itself. And of course, since the 450 megahertz net is a utility dedicated net, we support this net by providing backbone by using E.ON owned an E.ON owned fiber net, mainly running on top of the high voltage nets we're running all over Germany. So, but as said, and this I think is our topic, how to use the utility assets for communication. Power line is one of our pillars, and if we move to the next slide, we have also a certain history, and in difference to Iberdrola, E.ON started later with power line, but we immediately started with broadband power line in low voltage. And this now has a history for the last, let's say, 8-9 years approximately, where we did our first assessments of the technology, where we started piloting this technology, by this time based on the available technology, UPA, and then after piloting it with several thousands of installations in 2017, we had a clear board commitment in E.ON. Okay, broadband power line is the technology to connect and to build the last mile in the low voltage grid. Not in each grid, but in the grid where it's necessary, where we have a, let's say, bad coverage of public mobile, or where the cost of installation of power line can be amortized by being able to connect sufficient end nodes, to connect sufficient smart meters or sensors in the grid. So altogether, we started to then we started to set up our control center, since broadband power line by far is more complex to manage and to control than narrowband is. Where we generated, or we built our net management center. We started deploying UPA. Meanwhile, we have deployed more than 100,000 broadband power line units. We have set up a grid in over roughly 11,000 secondary substations plus the consequent houses. And we also, since we've seen that UPA is the beginning, we've seen that the development of this technology of broadband power line has to be done. So far, we came from a technology mainly applied in private houses to set up a house internal LAN net to connect a couple of computers or whatever, your router. But the way how to operate in the electricity grid is completely different. The way how nets are set up, the number of nodes that are connected is by far more than you have in private houses. So we've seen a lot of challenges in this time over the past years, and we gathered a lot of information and knowledge we wanted to bring in developing further the power line technology. And this was also the time when E.ON decided we have to get more active in the standardization groups by entering Prime Alliance, but also the Home Grid Forum and the ITU to develop further the G.HN technology that we dedicated or thought might be the broadband power line technology that has the most potential for the future to be also set up in electricity grid. And yeah, we did our first assessments of G.hn then starting in 2019 in a small number of nodes. We developed together with some component manufacturer, but also with the chip manufacturers, the technology. We set up a pilot, roughly spoken, or 3 pilots in fact, 1 year ago, to challenge G.hn also in bigger scale with a few thousand nodes installed. And now at this day, we are at a point where we can say, for our idea how we can observe the temperature, we have reached a point in which we say now we are ready for deployment G.hn as the next generation. And currently we are in a tendering process, and we have already planned our rollout with G.hn that is supposed to start in 2023, as soon as, of course, we have components available. And beside this, we are still working very hard, and the big achievements together in the Prime Alliance in interoperability, since this is the next challenge so far. Of course, you have a chip. Yes, you can have it in different products of different manufacturers, but it simply does not mean that this can be glued together and that it really works interoperable. And this is the next challenge. We are working on it, and we are really doing good progress in Prime Alliance to step forward at this point. And yeah, G.hn really, or broadband power line, for us is one of the core pillars in communication in the low voltage infrastructure. Okay, this is the end to what we are doing in E.ON. Thank you very much.
Okay, Marcus, thanks very much for that comprehensive overview of the situation in Germany. And I'm reminded as well of the energy transition, which Germany has been very proactive in to decarbonize. And of course, as with many things, there's the law of unintended consequences. As we move towards distributed renewable energy, we lose the benefits of centralized energy generation and system inertia and such things. And hence comes the requirement for ever more control and visibility at the medium and low voltage parts of the network. So fascinating to hear what is happening in Germany with E.ON in the 450 megahertz band. And certainly this is interesting as well to hear your activity in ITU, which EUTC participates in quite regularly, and also in 3GPP around a range of things about 5G future releases and spectrum standardization and harmonization as well. So, I mean, you may have partially answered some of the questions that I was going to ask, Marcus, but I'm observing that most of the origins of the power line carrier and BPL solutions seem to originate in the late 1990s, so maybe between about 1996 and 1999. And as Miguel mentioned in the intro, I was actually in the power company Norweb in Manchester at the time that they were developing their own power line carrier solution. And at that point in time, it was envisaged that the solution would be used for residential and domestic broadband connectivity. But of course, then with advances in ADSL type technologies, the technology solution of PLC and BPL didn't end up being used for consumers, but found a very new use and significant use now in massive connectivity for smart metering projects. But I wonder if you think, you know, it's time for that technology to be refreshed, and we could also increase the throughput and capabilities for consumer-based broadband using these types of technologies, especially in rural areas where it's still phenomenally expensive for anybody to install fiber optic cables. I wonder if you have any thoughts on that, Mark?
Well, I think it's not really in the intention of utilities, or at least not in E.ON, to come back to the 80s, 90s, where we wanted to become a telecommunication provider for private households or for private customers. I think looking to the current existing technology of broadband power line, it can provide, or it does provide, a rather good bandwidth, a rather good bit rate for smart grids. But in compare what DSL, fiber to the home, is currently providing, it's not a technology that can compete with. I mean, currently you're having 50 megabits per second using fiber optics in my private households where I live. By achieving this in with broadband power line, this is simply not possible. On the one side, you're talking about a shared medium. It might work if you have one house connected directly next to the head end that is maybe installed in the substation, but as soon as you connect more and more houses and that are sharing the bandwidth, this is decreasing. So nobody would be really happy by using broadband power line for the current applications we are running via DSL or fiber to the home. This is one thing. So therefore, there is no real application or way. The technology is, from my perspective, not sufficient for connecting or providing internet to private houses. Second part, of course, is also we are using power lines since we want to have our independent closed net for utility purposes, where we can keep our security on, where we can run our protocols on, and this doesn't really go in line with also providing this infrastructure and the technology for private use, where all of a sudden you have many open applications running in one and the same net and might cause any technical or security issues.
Mm-hmm. Okay, no, that's really good answer, Marcus. In the interest of time, I'm going to ask if I can bring Alberto back in. I have one or two more questions for both of you, and then we'll try and keep on track for the hour. So I think the first question we sort of covered before, Alberto, but again, I'd be interested to know in terms of the infrastructure sharing, and Marcus, maybe you have a better idea on this. I know where I'm from in the UK, only one power company has actually embraced infrastructure sharing, and they've done that quite effectively. So it appears to me that if you put the effort in, it's worth the effort for both the telcos and the power utilities. But is it really a significant enough revenue stream for an E.ON or an Iberdrola to generate money from this kind of thing? Or is it that there are still regulatory barriers that nobody has yet tackled because perhaps they appear to be too difficult to tackle?
Yeah, that is really a good question, a very good question. Being electricity business and telecommunications regulated in a very different way, the implications of doing this or that in terms of business makes a lot of sense since the beginning. I mentioned before that when we started with the deregulation in Spain, we started as Iberdrola to make a business out of building optical fiber networks for ourselves and the market. And this is the key thing, ourselves first and the market second. We were kind of, I wouldn't say visionaries, but clearly we had a vision of the importance of connectivity to reach our goals. Connectivity is not just reachability, it's not just reaching everywhere, but also having a network which is able to evolve. So as long as you have this combination of needs, the ones you have in your own, let's say, to solve your own challenges, and second, if you can make a revenue out of it. What we are seeing in the market is that the regulator, when it comes to the electricity business, is clearly seeing this in a different way. Probably they are starting to think that there are some incomes that are coming to utilities that should be captured by the regulator itself. This might be making sense, but on the other side, if the model is not the right one, if the model is not being thought since the beginning, probably it's going to prevent that this kind of synergies to be found between the electricity business and the capabilities to build optical fiber networks are not going to be boosted. So it is not just on the utility side to think on these ideas on how to help the market, but also to the regulator to get involved with the definition of the framework, because the uncertainty is the worst thing that can happen to a market. Things are not going to fly if they're uncertain.
Yeah, absolutely. And it is interesting, Alberto, as you mentioned, the regulatory differences between electricity and telecoms is sometimes a challenge. And certainly I know in a couple of countries there I've worked, particularly farmers have had big objections where they maybe get a nominal fee for having pylons in their fields to carry power. But if you put telecoms on there as well, they want a piece of the action, a slice of the cake, I guess. So is that similar in Germany, Marcus?
No, I would totally agree to what Alberto is saying. I mean, it's always looking to the infrastructure. Our purpose, our demands is coming first, and beside the regulation itself, if there is then something left. We can discuss of renting some capacity or something to any third party, but this is a minor portion and by for sure not in focus of our business.
Mm-hmm. Okay.
I would add to that that it is just thinking that regulation for utilities just monolithic is also not the right approach. When we are referring to utilities here, we are mainly referring to distribution companies. Distribution companies is regulated in a very special way. Clearly, retail is regulated in different ways. Different countries do have different approaches. But clearly, when thinking on the regulation for the distribution companies, which are probably the most affected ones in terms of reusing the assets, we need to think about that also from the regulatory perspective, but having regulators from the two markets, the distribution of electricity and the telecommunications, helping each other, understanding the situation and see how a framework, the proper framework might be having a success.
Absolutely. No, thanks Alberto and Marcus. I mean, I'm just keeping an eye on the clock. I can see we only have 3 or 4 minutes left. So as they say, time flies when you're having fun. So I think this conversation will definitely stimulate other discussions as well. And I think we have other questions online as well, which can be answered outside of the live session at the moment. And I believe that the session is recorded, so people can access it later on. So Marcus and Alberto, thanks very much for the presentations this morning. We could have done more questions, but I'm keen that we stick to the hour. So if it's okay, I will hand back to Miguel Sanchez for his thoughts and closing remarks. Gentlemen, thanks again for excellent presentations today. See you again soon. Miguel, back to you.
Thank you very much. Thank you so much, gentlemen. Very interesting remarks, very interesting discussion. I have seen that there are several questions on the chat, and perhaps, Julian, you want to make a look to that. Those are technical, very detailed questions, but I'm sure that they will be quite interesting to answer about, the bandwidth of on the capacity of the broadband power lines and confronting with the 450 megahertz. I have seen several questions about that. If we are not able to answer them in the panel, as you said, be sure that all the ones that have asked about these questions, they will be answered later on. Let me just make a couple of comments as a conclusion. First of all, I mean, the sharing of infrastructure between the telecom world and the power works and the power world is something that is available, is possible for use to be used for both sectors. But as Alberto has said, perhaps it's not very much boosted because of the of the, I would say, the difference on time and the difference on processes. The real point now for today is, in my opinion, utilities, European utilities especially, have a clear challenge for, let's say, supporting a faster energy transition. And the energy transition is requesting a very fast modification of our networks. You have to convert the networks, the power networks, into a smart grid very much, I mean, in most rapid way that has been ever thought. This is quite an important point. We are really invaded by distributed energy resources. We are really invaded about the plans for the electric charging, and our networks have to be built with enough connectivity. And I underline again the word of connectivity. Alberto has said something that, in my opinion, is quite relevant. Low voltage is everywhere, but telecoms are not everywhere. And this is a real point. I mean, we have to arrive to enough connectivity in the low voltage. And low voltage is the most extensive part of our networks that has been really forgiven from the point of forgiven from the point of view of the digitalization for a long time. Now it is the point, and as Marcus has said, they are thinking that the secondary substations are becoming a digital hub of the future, because we are going to need digital hubs. And for all of this, that's why Marcus has probably confirmed us that BPL is the technology to connect the last mile in Germany. And this is, of course, not taking into account services for consumers, as you know, internet connection or Netflix connection. No. We are talking about the last mile for allowing this energy transformation to the user. And this is in my opinion, the real point. We have a lot of things to do, and that is exactly the main point of our title for the event today, is the use of power assets for the services that are needed for the energy transition. That is exactly the point. And my conclusion would be, please, do not forget power assets. Do not forget fibers. Do not forget power lines. That is exactly the point. We are not going to forget another telecommunications technologies. We are not going to forget another telecommunications opportunities, and of course, many services coming from the telecom operators. But do not forget our power assets. That would be my conclusion. And thank you very much for all the attention and all of you that have been attended. And I will pass now to Ashley for the final conclusion.
Thank you very much. And on behalf of the Prime Alliance, Ennet Europe, and Smart Energy International, I would like to thank our experts for sharing their interesting insights and perspectives with us today. And I'd like to remind you that a recording of today's webinar will be available on the Smart Energy International and Ennet.world websites for you to view on demand. Until we meet again, please keep well and stay safe.
Thank you.
Bye.
Bye. Thank you.
Thanks a lot.